Hi, I'm Patrick Reagan. Welcome to the Wireless Networking, Part 1, Wireless Networking Components and Infrastructure. During this video, we will go deeper into the wireless technology that was discussed in earlier videos. It will cover the type of signals used in wireless networks, type of antennas, cellular topology, type of wireless networks, wireless access points and its placement, and wireless LAN controller. Wireless technology provides the ability to communicate between two or more entities over distances without the use of wires or cables of any sort. Most wireless networks use radio waves. Another form of wireless uses microwaves. The most common network connection is the 802.11 Wi-Fi. Bluetooth is usually used to allow access to local devices that form a personal area network. 802.11 Wi-Fi and Bluetooth use radio waves. The radio waves have the frequency range from 3 kHz to 1 GHz. These waves are easy to generate and they can travel along a long distance. These waves are omnidirectional in nature, which means that they can travel in all directions. They can penetrate through normal walls very easily. They're used for AM and FM radio, television, cellular phones, and wireless 802.11 Wi-Fi. The 802.11 Wi-Fi 2.4 GHz radio signals can travel up to 150 feet indoors and 300 feet outdoors, while 5 GHz signals have a short range of 50 feet indoors but offers faster speeds. One of the types of wireless networks that is based on radio waves is cellular broadband. Cellular broadband, such as 4G or 5G, uses mobile networks, LTE, 4G, or 5G for broadband access. 4G LTE speeds are up to 100 megabits per second with ranges of up to 10 miles. 5G speeds are up to 20 gigabits per second in ideal conditions, but only have a range of about 1,000 feet. However, in real-world scenarios, average download speed is typically 100 to 300 megabits per second. 5G offers low latency and high speeds. It offers high mobility and rapid deployment, but is dependent on cellular coverage. It may have data caps or higher costs for extensive use. It is often used in mobile offices, temporary sites, and backup connections. Microwaves are electromagnetic waves which have a frequency range between 1 GHz to 300 GHz. Microwaves can travel up to 30 to 40 miles or 48 to 64 kilometers, although not as long as high-powered radio waves. Microwave signals can deliver data rates ranging from 300 megabits per second to 25 gigabits per second, and even higher in some specialized scenarios. It is unidirectional in nature, which means that they can travel only in a straight line. It requires a clear line of sight between the transmitting and receiving antennas. These high-frequency signals do not penetrate into walls. These waves are usually used for one-to-one communication between sender and receiver, cellular phones, and wireless LAN. Satellite is a form of radio networking where it is non-terrestrial communications using high frequencies of 1 to 30 gigahertz. Satellites can provide coverage over vast geographical areas, including remote and rural regions. Satellites may be necessary for remote sites and difficult to network sites. Similar to other microwave communications, satellite communication requires a clear line of sight between the transmitting and receiving antennas. It is a high cost relative to terrestrial networking. Typical speeds may be 50 megabits down and 3 megabits up. Due to the long distance that signals must travel from the Earth to the satellite and back, satellite communication often experiences higher latency compared to terrestrial microwave links or other forms of communication. High latency is 250 milliseconds up and 250 milliseconds down. Because of latency, jitter may occur, which is caused by the variation and delay of packet transmissions over a network. Antennas are devices that transmit or receive electromagnetic energy in a way suitable for a specific application. An omnidirectional antenna is a type of antenna that radiates or receives electromagnetic signals uniformly in all directions in a specific plane. Most access points in cellular networks will include omnidirectional antennas. An omnidirectional antenna provides 360-degree horizontal signal coverage like a donut-shaped radiation pattern around the antenna. The signal spreads evenly in all directions horizontally, but has limited coverage vertically above and below the antenna. We typically place the wireless access point or antenna in the middle to cover more area where users would be. Ideal for central placement in an open area where clients out in all directions, such as office floors, open rooms, and warehouses. It is a good choice for most environments. It's easy to install since it does not require precise aiming. Omnidirectional antennas usually have a lower gain compared to directional antennas. A directional antenna is used to focus the signal, allowing for increased distances. It provides a point-to-point communications. It sends and receives in a single direction. By focusing the signal in a specific direction, directional antennas can reduce interference from unwanted sources. Directional antennas typically have higher gain, measured in decibels, resulting in stronger signals in the desired direction. The most common types of directional antennas include Yagi antennas, parabolic or dish antennas, and sector antennas. Yagi antennas are known for their high gain and ability to focus signals in a specific direction. Dish antennas are used for long-range point-to-point links. Sector antennas are arrays of directional antennas that work together to provide omnidirectional coverage such as those used in cellular networks. Panel or patch antenna is a semi-directional 30 to 90 degree beam width to cover a specific area. Directional antennas are often used to bridge a gap where antennas are placed at both ends. It is used by microwaves and satellites. Many wireless technologies, including cell phones and 802.11 Wi-Fi, use a cellular topology where an area is divided into cells. A broadcast device is located at the center and broadcasts in all directions to form an invisible circle or cell. All network devices located within the cell communicate with the network through the central station or hub. Cells are interconnected with the rest of the network infrastructure. If cells are overlapped, devices may roam from cell to cell while maintaining connection to the network. A dead zone is an area that isn't receiving cell signal. It's caused by being too far away, being blocked by a building, mountain, or something else in the environment, or in an area that does not have coverage. In wireless networks, there are 4 types of networks: mesh, ad hoc, point-to-point, and infrastructure. A point-to-point connection is a dedicated connection between 2 devices only, typically used for long-distance, high-bandwidth links. It requires line of sight between the 2 devices. Examples include a wireless link between 2 buildings using dedicated microwave antennas. Mesh refers to a network where devices connect directly to multiple other devices, creating a flexible and resilient network with no single point of failure. Decentralized connectivity, where every node acts as a repeater or router. It has decentralized connectivity, whereas every node acts as a repeater or router. Multiple nodes connect to each other directly, creating redundant pathways for data transmission. It is self-configuring and self-healing as nodes automatically discover each other and form connections, and the network can reconfigure itself when nodes are added or removed. It is well suited for large areas with potential for dynamic changes in network topology. Examples might be smart city infrastructure, where sensors communicate with each other across a wide area. Ad hoc, also known as Independent Basic Service Set, or IBSS, describes a temporary peer-to-peer network where devices communicate directly without a central access point. Devices connect directly to each other without a central access point, often used for temporary setups like file sharing between nearby devices. Example, a group of people sharing files during a meeting using their laptops. Infrastructure describes a network that relies on central access point for devices to communicate through. Devices connect to a central access point, like a wireless access point or wireless router, to communicate with each other. Most common types of wireless network offering centralized management and control. Example, a home Wi-Fi network where all devices connect to a single router. A wireless access point, or AP, is a networking device that allows wireless devices like smartphones, laptops, and tablets to connect to a wired network, essentially acting as a hub that enables them to access the internet by bridging the gap between wireless and wired connections using Wi-Fi technology. It's a central point for wireless communications within a local area network. It typically connects to a router or network switch using an Ethernet cable, which will allow internet access through the wired network. For larger areas, organizations may need to install multiple wireless access points to provide full coverage. These devices would typically manage with a wireless controller or cloud controller, which is a wireless controller hosted in the cloud, or will be deployed as part of a mesh architecture where the mesh nodes would connect to a root node that acts as a gateway for internet access. Wireless access points need to be secure too, but the security may be limited by the need to provide coverage and accessibility. You may consider placing the wireless access points in a secure room, but they usually need to be placed where they can cover the clients. Therefore, install your APs in a central location, away from any corners, walls, or other physical obstructions, if possible, to provide maximum signal coverage. For larger places and/or multiple floors, you may need to place multiple access points. You may consider placing them in high points in an office or building. Remember that you may need to power cycle the wireless access point. A wireless LAN controller, or WLC, is a device that manages and optimizes wireless networks. It's essential for maintaining robust and scalable wireless networks, and it can help minimize traffic flow issues and bottlenecks as the network grows. It's a key component of networking, especially for large-scale or distributed networks. The WLAN controller provides centralized management by managing multiple access points or APs in a network, simplifying administration. It improves network performance by automating tasks like load balancing and firmware updates to improve network efficiency. It ensures security by help detecting and neutralizing threats based on user ID and location. It reduces downtime by helping maximize uptime and availability by allowing network updates to be deployed without going offline. The WLC is usually located at the data center where all wireless APs on the network connect to it. Wireless controller with controlled-based APs provides centralized management of APs, supports fast, secure roaming protocols, and can enforce roaming thresholds, load balancing, and band steering. It is ideal for environments needing seamless handoffs such as VoIP and video conferencing. A wireless autonomous access point operates independently, managing its own configuration, and functions without relying on a central controller. Autonomous access points are suitable for small networks. Autonomous APs can become cumbersome to manage in large deployments since you have to configure each one individually. A lightweight access point relies on a network LAN controller, or WLC, for management and configuration, essentially acting as a lightweight device that receives instructions from the controller to function effectively. Lightweight access points are better for large, centrally managed networks. Lightweight APs communicate with the WLC using the Lightweight Access Point Protocol, or LWAPP. A wireless router is a device that not only provides wireless access like an AP, but also manages network traffic and acts as a gateway to the internet, typically including features like firewalls, router, DHCP services, DNS services, and network address translation, or NAT. Wireless routers are commonly used in homes and small offices to provide internet access to various devices like laptops, smartphones, and tablets, and typically include Ethernet ports for connecting wired devices like desktop computers with a twisted pair Ethernet cable with an RJ45 connector. Question. You need to support a remote area that does not have a network infrastructure, including cable or DSL. What is the best solution without adding external infrastructure? Answer: satellite. Question. Which has the highest latency? Answer: satellite. Question. What would be used as a network repeater to connect a far office to the main office that is separated by a canal? Answer: directional antenna. Question. What type of antenna does a typical wireless access point use? Answer: omnidirectional. Question. Which of the following devices will be used to manage a corporate WLAN? Answer: a wireless controller. Question. Which of the following has the capability to centralize managed configuration, logging, and firmware versioning for distributed devices? Answer: WLAN controller. Question. A network architect needs to create a wireless field network to provide reliable service to public safety vehicles. Which of the following types of networks is the best solution? Answer: mesh. Question. Which of the following OSI model layers does a MAC filter list for the wireless infrastructure operate at? Answer: data link. Question. You need to connect two laptops directly to each other using 802.11 AC, but does not have an AP available. Which of the following describes this configuration? Answer: independent basic service set. Question. What is independent basic service set known as? Answer: ad hoc. Question. Which of the following network devices converts wireless signals to electronic signals? Answer: access point. Question. A network administrator is designing a wireless network. The administrator must ensure a rented office space has sufficient signal. Reducing exposure to the wireless network is important, but is secondary to the primary objective. Which of the following would most likely facilitate the correct accessibility to the Wi-Fi network? Answer: antenna type. Question: several users with older devices are reporting intermittent connectivity while in an outdoor patio area. After some research, the network administrator determines that an outdoor WAP might help with the issue. However, the company does not want the signal to bleed into the building and cause interference. Which of the following should the network administrator perform to best resolve the issue? Answer: install a directional WAP in the direction of the patio. Question: which of the statements listed below best describe a wireless mesh network topology? Answer: self-healing, decentralized network ensuring continuous connectivity across large areas. Question: which of the following answers refer to the key features of wireless ad hoc networks? Choose two answers. Answers: temporary connections and direct links without an AP. Question: which of the following answers refers to the key features of point-to-point wireless networks? Choose two answers. Answers: long distance, high bandwidth links, and dedicated connections between two locations. Question: which wireless antenna type provides 360-degree horizontal signal coverage? Answer: omnidirectional antenna. Question: which of the answers listed below refers to the common antenna type used as the standard equipment on most APs for indoor wireless LAN deployments? Answer: omnidirectional antenna. Question: which of the answers listed below can be used to describe an autonomous AP? Choose three answers. Answers: well suited for networks with fewer APs and simpler needs. Each AP is configured and managed individually and operates independently without a controller. Question: which of the following statements refer to lightweight APs? Choose three answers. Answers: requires a wireless LAN controller for centralized configuration and management, best for environments with multiple APs requiring uniform management, and easily expandable with minimum configuration effort. For more information, visit these sites. In summary, wireless technology provides the ability to communicate between two or more entities over distances without the use of wires or cables of any sort. An omnidirectional antenna is a type of antenna that radiates or receives electromagnetic signals uniformly in all directions in a specific plane. A directional antenna are used to focus the signal, allowing for increased distances. Many wireless technologies, including cell phones and 802.11 Wi-Fi, uses a cellular topology where an area is divided into cells. In wireless networks, there are four types of networks: mesh, ad hoc, point-to-point, and infrastructure. Ad hoc, also known as Independent Basic Service Set, or IBSS, describes a temporary peer-to-peer network where devices communicate directly without a central access point. Infrastructure describes a network that relies on a central access point for devices to communicate through. A wireless access point, or AP, is a networking device that allows wireless devices like smartphones, laptops, and tablets to connect to a wired network, essentially acting as a hub that enables them to access the internet by bridging the gap between the wireless and wired connections using Wi-Fi technology. A wireless LAN or WLAN controller, or WLC, is a device that manages and optimizes wireless networks. A wireless router is a device that not only provides wireless access like an AP, but also manages network traffic and acts as a gateway to the internet, typically including features like firewalls, routers, DHCP services, DNS services, and network address translation, or NAT. Thank you for watching this video. The next video will be Wireless Networking Part 2, Frequencies, Channels, and Wireless 802.11 Standards. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.